Hey guys, welcome to your first geometry lesson. It does say lesson 9.2. That's because we do have a textbook that we'll end up getting into later, and it does follow the order that the book calls these chapters in. And so we're actually going to do 9.1 tomorrow. It's just because this is the easier one. It's like, get your foot in the door, let's see what this class is about. Quick general comment. Normally, even if we were face-to-face on a non-pandemic school year, we don't provide printed out notes, right? So typically in a day's class, you're just gonna sit down, write down what you think is important, follow along on the parts you want to follow along with, write down examples you think are key to you, but we would always provide a worked out version of those notes on Canvas later. So if somebody wanted to write things down but felt they missed something, they could always go back and recopy it. And part of that is kind of just prepping you for what college is like. You gotta just write down, type, do whatever you gotta do. So I'm just letting you know that we do have these available. You're welcome to print them off if that's your preference, but not a requirement, right? So just if you have a spiral notebook or even graph lined paper notebook, I often recommend graph paper notebooks so you can graph if you need to. It's up to you, your own organization, do what makes you happy. All right, so let's go ahead and get started. Normally I won't talk so much at the beginning of a lesson. It's just, hey, first video, some quick reminders. So we're looking at translations. So a couple of quick definitions we have going on here. So transformations in general are the things that change and move something on a graph, right? So it can physically be a graph like a y equals mx plus b or a quadratic graph and the things that move it around. We can also, a lot of times in geometry, we're just going to refer to points and segments and just move them around. So a transformation is anything that does that. The first three that we're going to look at are a translation, which slides or moves something around. A reflection is a physical flip across a specific line that we're going to look at. Rotation is turning from a center of rotation. It could be the origin, could be any point. And the dilation, which we're not going to cover until a little bit later, that's what physically grows or shrinks a figure on a plane. And if you remember from graphing lines or quadratics, these would be the same effects that would cause the slope to get more steep or less steep, or make the parabola more narrow or more wide. So that's the kind of thing that changes the physical shape. We refer to the original image or the original graph, the original point, whatever that is, as the pre-image. And then once it's been moved, we refer to that as the image. And so that can kind of be a little bit goofy at first, but the word pre reminds you that is the beginning. And that's really important because if a problem is saying something like, hi, here's the image, how do I get back to the pre-image? We're actually referring to the steps to go in reverse. Whereas I go, here's the pre-image, here's the transformation we're gonna do, give me the location of the image, we know we're reading that forward. So it might seem like a kind of no-duh, makes sense thing, but that would be a place where we'd want to be careful. A vocab word you've likely not heard before is called isometry. And isometry is basically some type of change or transformation that, although we've possibly moved it around, we have maintained its congruency. So it is still the same size and it is still the same shape. So a quick in-your-head question just to give you something pretty easy to think about. Of the four that are here, which is the one that is not going to be in isometry? If you guessed dilation, you're right. If you just stood there and stared at the screen like, come on, dude, give it the program. Also dilation, right? That one changes it. Anything else is just sliding around, flipping around, rotating it, won't change the physical size and shape dimensions of that. And last, what we refer to as a composition is when we apply more than one transformation in a set and are just talking about that there are multiple pieces of it. So, a couple of quick things again. I don't want to bore you to tears, but again, the translation is when we're sliding, the reflection is when we're flipping something, rotation is when we're turning something. The notation that's really important is up here. This little, they call them prime, you can call them little ticky marks, they look kind of like quotation marks. They basically, if you didn't see those in junior high, they denote the difference in the image, the pre-image, the image, and then further iterations of that image. So for example, a random point called P, that's its pre-image, and then if we've transformed it once, it would have a single tick mark. If we have transformed it twice, if we transformed it 3 times, etc. And sometimes we'll call that P prime, P double prime, or just however you want to refer to it, but that is the notation that we're going to see a lot of times. And again, it seems self-explanatory, but it's really important. If I tell you in the problem, here's the location of P prime, tell me where P is, then I understand, oops, I need to go backwards. So that notation would be important in a situation like that. All right, so let's look at a quick graph. There's a lot of different ways that they can write these transformations. This is one of the more standard ways that says, okay, take the original point x, y, and we're going to change it to x plus 3y plus 2. If this were the answer, and I haven't even read this question yet, but we can write that. A lot of times you'll even see a giant T for translation of x, y is this. I've seen it written like T, in this case, plus 3 plus 2, it'll be like 3 comma 2. I've seen it T with parentheses, 3 comma 2. All of these different ways of writing it are just saying it's a translation and you're going to add or subtract that amount to the x and y values. So checking out what this question is saying, we've got a soccer ball that has gone from position 1 to 2 to 3 to 4. Give me the correct translation from 2 to 3. So we are at this point, we're going to here, the x value is what we read first. It went towards the right, 1, 2, 3, so it went plus 3 on the x, and then it went down 2 on the y. So we would just be looking for one that is referring to the x going plus 3, the y going down 2. It is extremely common to not write this as plus -2. In fact, for me, because I don't like to write a whole lot, I would 100% have written y minus 2. Okay, but just for your knowledge, either of those things are okay ways to represent that. All right, so again, here's what I was kind of talking about, that sometimes they add that little T in the front to let you know it's a translation. Let's just run through some examples real quick again. So here is the description, and the difference in these two, I'll call it like kind of the example part A and part B. Here's one where I want you to tell me where it is at now. This is telling me where was it. So the difference in asking for what is the new image versus what is the pre-image. This diagram, it's kind of clear which way you're going, but they could use that vocabulary or that notation without this big hint. So that's why I'm kind of pointing out those things are important. That way you know which way to go. So here we're simply going to plug in x here. So 1 subtract 2 is -1. And then -4 add 3 is also -1, just by coincidence. For this problem, we're looking for what x value did I subtract 2 from, and now I'm at -3. And sometimes you have ways to think about it. For some students, they like to think about this and just go backwards. So instead of minusing 2 to come here, they're going to plus 2 to go that direction. Anything that makes you happy. If I plus 2 this direction, I'm going to land at -1 again. And some students like to just triple check. Let's say this was a quiz, -1 minus 2, -3. Okay, cool, I did that right. And so then going backwards here, we're going to need to subtract the 3. So 6 minus 3 is 3. And again, you can read that forward, 3 plus 3 is 6, just to make sure that you did that right. Okay, got it. I'm not too concerned about you being able to deal with a single point. Or we might have situations, let me see if it's coming up, no, where they give you like 2 points and it's a segment and you'll have to move both of them and you just kind of reconnect them. All of that is pretty straightforward and probably what you did in junior high. Something that might be a little bit new is taking an entire mx plus b linear graph and then sliding that around. And in this case, it also wants me to write what is that new equation. And I'm picking an example that starts out a little bit easier than one that's a little bit trickier to kind of remind you of some algebra stuff. Without going into details and boring you on your first day of geometry class, a lot of algebra, unfortunately, depending where you had your course, was taught on a graphing calculator. And what I mean by that is they taught you how to go in and type in the system, get the answer. Do n solve, get the answer to an equation. Graph something, it's there. We do not use the calculator in advanced mathematics with extreme exception. So this isn't just say, well, you're at home, I don't have one, or I'm at home, what you gonna do about it? I got one anyway. I understand. I'm just letting you know that generally in class, we don't use them. If you continue in pre-AP and go to Algebra 2, pre-calculus, calculus, they also very rarely use them unless it's for something specific. So if you are at home, I would recommend that you start to get in the habit of trying to do your little arithmetic, all of your algebra like by hand. Again, you're at home, It's quarantine. If you want to get out your calculator and triple check your answer, a particular quiz or a test, I'm not going to know the difference. But I am letting you know, if we do end up seeing each other again, whether it's my class or if it's next year in your next class, whenever that may be, we do not have the calculator access to us. And just a fast note, we're also not going to ask you to do 237 times 8.62, right? That's a waste of our time. But we are going to ask you to be able to know your math facts. Like 6 times 7 is what? 42, okay, things like that. We want to get that back in your system, and I promise every single year, I tell people we don't have the calculator, their gut instinct is, and they freak out, and then all of a sudden they're okay after like 3 or 4 weeks of just doing math again. All right, back to the question. Y equals x plus 5. So we are looking at y equals mx plus b. This is slope-intercept form, where this is where we would start the graph on the y-axis, and this is the slope that we would count for making the graph. So for our first example, the y-intercept is at 5, so 1, 2, 3, 4, positive 5. The slope, if it's not there, is an invisible 1 over invisible 1. So up 1 over 1, up 1 over 1, as many times as makes you happy. And then here's the original line. It's asking me to use this translation. So minus 2 means we're going left in the x direction 2 spaces, and we're going up in the y direction 3 spaces. You can honestly pick any or all of these points to do this to. I typically like to grab the y-intercept just because it's the most obvious point that I started with. I'm going to walk that one back 2 spaces and up 1, 2, 3. Okay. You can do that for all of these points. Like here you go back 1, 2, up 1, 2, 3. For this one, back 2, 1, 2, 3. But what you'll start to notice, and it is important to observe this, that the slope ends up not changing. So we're just taking the line and moving it. So no matter what the up and over was, that's going to be maintained. So once you get that first point, you can also just recount your 1 over 1 or whatever the slope may be on a different question. All right, this problem I picked as a starter example because the y-intercept ends up landing at a nice point that's easy to see and easy to read. So the answer here is y equals the same slope, 1 over 1, and it is touching at plus 10. What I want you to see is what if, number 1, this point ends up like way off the graph where it's uncomfortable to kind of keep counting it up, or even more importantly, if it's something that's like a fractional slope and this point doesn't even land nicely. So it's not something that you can be like, oh, it's at 4, done, plus 4. Okay, that'd be great. What if the answer lands at like a decimal fraction? So I do want to work through one final example that addresses that. So y equals 2/3 x plus 1. Start with that y-intercept at up 1. The slope is 2 over 3 positive, so up 2 over 3 is the slope movement. So 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Do it enough times that it makes you happy. Arrow, connect, arrow. So here again, pick any point you want. I'm going to start with this y-intercept. We're using the same transformation, so it's still going to go left 2, up 3. So left 2, up 1, 2, 3. Let's do one more point, left 2, 1, 2, 3. Again, you'll notice the slope is maintained. This is still a 2 over 3. So you can keep counting from here, or you can just count the slope at this point. 2, 3, 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Okay, so here's the new graph. So this slope here we know is going to stay the same. So y equals 2/3 x something. And maybe if this was a multiple choice, we could use some educated thinking here and go, okay, looks like it's landing between 5 and 6. I don't know how much. It's definitely, or because of the fraction involved, it's not like it's a clear and obvious 0.5 where I could make that assessment. So I did want to walk through how do I solve for that if I don't know. And although there are multiple ways to do this, one of the typically first taught ways to do this is to understand like plus b is what I'm trying to figure out, and I need to borrow an x and a y value from the line I'm talking about. So that would be any of these blue points. 100% of these points are okay to use, so you just got to pick one. Some people might pick this one because it was the first point they moved, at -2, 4. Somebody else might want to pick a point that's all positive, like this is at 1, 6 or 4, 8. The beautiful thing is 100% when you're done, this answer is going to be the same. For me, I'm going to use a double positive point that has the smallest numbers available, just because I feel like that's going to keep the problem a little nicer. So I'm using x value 1, y value 6 as my point. So I'm borrowing 6 for y, 2/3 times x value 1 plus, and I'm trying to figure out that b value. And I like to use a capital B just so it doesn't look like a 6 on accident when I start writing too fast. So if you don't know how to multiply fractions, it's top times top, bottom times bottom. So 6 equals 2 times 1, 2, 3 times 1, 3, plus b. I need to subtract this 2/3 away from b. So b ends up equaling 6, subtract 2/3. And if I don't have a calculator in front of me, I need to work that out. So I'm going to need a common denominator. In this case, we're going to times by 3 over 3. This will become 18 over 3 minus 2 over 3, which is 16/3. So my final answer is y equals 2/3 x plus 16/3. And any of these other points you used, once you got to the fraction step, it might look physically different for a moment, but it ends up reducing down to 16/3. If you want to try one of the points just to see how it goes, you can do that. Okay, that's your lesson for today. The homework, of course, is going to be online. You will have the choice of printing that out and then filling it out, taking a picture and sending it in. You're also welcome to just take a sheet of paper, number the problems, and just write down your answers to them. Any work, this one this might need some work, but there might be something like, dude, it's just count the point. I got where it's at. Like, I understand that, but just moving forward throughout the year, some problems are gonna require some work, some I know you can do in your head. So I'm a little understanding when it comes to that. But if there is any work, make sure that's there and make sure your name, your full first and last name, is on that page when you go to take the picture and send that in. Okay, otherwise, good luck, have a good day, and see you next time you log on.